Welcome to BrainBox. Now we are looking the concept of heat and temperature. So in our previous videos we have studied and we have distinguished between the heat and temperature. Now the time comes to look at the units of heat. So generally the heat is measured in joules. SI unit of heat is joules and CGS unit is calorie. And it is a common practice that in mechanics, whenever the energies come into picture, we use joules as the unit. But in case of thermal physics, we need to use a CGS system, that is calorie. So obviously, calorie is a bigger unit compared to the joule. So how much bigger it is? So you can just look at the equality between the calorie and the joule, that is 1 calorie is equal to 4.186 joules, 4.186 joules. So calorie is a bigger unit in fact. So how can you define that? So to define the calorie, you can define it as the amount of heat required to rise in temperature of 1 gram of water by 1 degree centigrade is called as calorie. So what is a calorie? 1 calorie is that amount of heat required to raise the temperature of a 1 gram of water by 1 degree centigrade. Okay. Now, once you are aware of the units of heat, and it is also important to know the units of temperature. So, units of temperature, as we know in our common practice, we take the degree centigrade. That is what called as Celsius in fact in common practice. So that's the unit of a temperature, but the Kelvin is supposed to be the SI unit. So SI unit of temperature is Kelvin. So heat and temperature, the units we have seen. Now we'll proceed to the relationship between the kinetic energy and temperature. So you can see that, you can just make out, it can be observed that average kinetic energy of molecules or particles of a hotter body is greater than that of the colder body. That means hotter body, the particles in a hotter body are having more kinetic energy compared to that of the cold body. So the average kinetic energy of the molecules is directly proportional to the absolute temperature. So just now we said the kinetic energy of the particles is more in case of the hotter body and less in case of the colder body. So there should be some relationship between the kinetic energy and temperature. So what is the relation here? The proportionality relation. That's the reason you can write the average kinetic energy of the molecules is directly proportional to the absolute temperature. So Ke is directly proportional to T, and here it is capital T because you are taking the absolute temperature, Kelvin scale of temperature. So that's the reason you are taking capital T over here. Now, once you have the relationship between the kinetic energy and temperature, and it is also necessary for us to discuss something about the specific heat of a substance. So what do you mean by a specific heat? The next question arises to define the specific heat of a substance. So let us now look at what does it mean by a specific heat. Specific heat of a substance is the amount of heat required to raise the temperature of unit mass of substance by 1 unit. Or in other words, you can also define as the amount of heat required to raise the temperature of 1 gram of substance by 1 degree centigrade. Or 1 kg of substance by 1 degree centigrade. So you can take the unit amount. So when a unit mass is taken, in order to increase its temperature by unity, how much heat is required, how much heat energy is required, that is called as the specific heat. So what is the relation? How can you calculate this? So as I said, the amount of heat required to raise a unit substance is the specific heat. Suppose the mass is increasing. If quantity is increasing, then obviously you require more heat energy to raise its temperature by 1 degree. That's the reason Q is directly proportional to mass of the substance when temperature remains constant, and Q is directly proportional to temperature of the substance when mass remains constant, which means altogether I can write the heat energy required to increase its temperature by unity is directly proportional to the product of mass and change in temperature. So Q is directly proportional to M into delta T, I can write. So when I remove the proportionality, I have to put one constant. So that constant I am taking as S. So if I remove the proportional, then I have to write Q is equal to Ms delta T, where S is the proportionality constant called specific heat of a substance. So now how can I write the expression for specific heat? Specific heat is equal to Q divided by M into delta T. So that is what called as the specific heat of a substance. So specific heat depends upon the nature of the substance, of course. All the substances will not have the same specific heat. So here, once I am able to write the expression S is equal to Q by M delta T, then it is easy for us to write the SI unit of the specific heat. SI unit can be written as what now? So Q is joules and mass is in kgs and temperature is in Kelvin. So SI unit of specific heat becomes joule per kg Kelvin. And if at all you take in CGS unit, it will become calorie per gram degree centigrade. And here you can also look at the conversion factor. 1 calorie per gram degree centigrade can be 420 joule per kg Kelvin, because I have given you the conversion formula for calorie to the joule. So using that, you can just look at 1 calorie per gram can be taken, 1 calorie per gram centigrade can be taken as 420 joule per kg Kelvin. So this is how you can write the units. Now, what is the actual need of this specific heat and what exactly it tells about? To know that, you can just look at the thing. If the specific heat of any substance is high, then the rise or fall, the rate of rise or fall, meaning that in a stipulated time, the increase in temperature or decrease in temperature will be very low. So, using this concept, you can easily distinguish between the water and oil. So, oil gets heated earlier than water because the specific heat of oil is less. So, its rise will be faster, rate of increase is faster. So, you can just think about the reason why oil gets heated earlier than water when they are heated at the same temperature, because the specific heat of oil is less than the specific heat of water. When the specific heat is less, then rate of rise will be more. Specific heat is high, the rate of rise will be less, vice versa concept. That means inversely proportional, you can say. Specific heat is more, then rise or fall will be low. Okay. So, this specific heat depends upon the nature of the substance. So, oil having the different specific heat and water is having different specific heat. So, water has more specific heat than oil. That's the reason oil can be easily heated compared to the water. So, here we have seen the expression K is directly proportional to T. That means the molecules of the system have different forms of energies such as linear kinetic energy, rotational kinetic energy and vibrational kinetic energy. So these are the different types of energies. Apart from this, you also have potential energy. So this energy together is called as an internal energy of a system. When a heat is given to the system, it will be shared by the molecules in various forms. So the maximum share of heat energy is utilized in increasing the kinetic energy, and so that the temperature is changing. That is why the specific heat is different for different substances. That means it totally depends upon how the energy is getting shared amongst the molecules.